Hi everybody, this is your overview video for your Unit 3 Engineering Design Challenge, which is Parachuting into Victory, which pretty much just means what we're looking at right here. So your overall goal for this project is to be able to build a parachute that has the lowest acceleration when you drop the parachute and your paratrooper off the top of the stadium. You do have some constraints in terms of your materials for this lab, so you have the choice per prototype to decide if you want to use 3 of these grocery bags or if you want to use 1 large trash bag. It's up to you what you choose, but you ultimately will have 3 prototypes. So you can decide to use maybe the 3 grocery bags for the first prototype, the large garbage bag for the second, and then kind of decide what works best for the third. The only thing you can't do is you can't combine those 2 together. So per prototype, you can decide what you want. You just can't bring them together. You will also get 1 piece of newspaper. So this is the full piece, and then you have 1 meter of tape and 2 meters of string. Overall, your construction expectations is you do need to build a minimum of 2 prototypes and then 1 final design. So you do have to have a total of 3 parachutes. All 3 parachutes must be tested. Now, what you may find is your first 2 parachutes you will probably test in one of the stairwells. So we talked about that the other day. You may choose to do the stairwell that's near the pack, so that nice big one, or you may choose to use the one that's right next to the science wing. Kind of depending on where your parachute goes, one may be better than the other. But you do need to collect data for each and every one of your parachutes. The last one, or your best one, we will be testing down at the stadium, but either way, you may want to actually test it inside first, again, to see which is your best one, and then we'll go down to the stadium to do your final trial. Now, notice that I say here, both prototypes should be tested, data must be collected, and the given versus known chart must be completed in full for each prototype. So that means that you know the initial position, the final position, the initial velocity, calculate the final velocity, the acceleration, which you also have to calculate because this is not going to be acceleration due to gravity since we have that resistance, so it's not in free fall, and then time. So everything should be getting a number. Now, some of those numbers might be 0, but there still should be a number for each and every part of that given versus known chart. Again, lab expectations, ultimately you are going to determine acceleration and final velocity of your paratrooper once we test down at the stadium, but that's just your final test, like the one where we're going to compare to your classmates. You are still collecting data for each and every prototype while you're in class, so in the stairwells, in the class, and then when we go out to the stadium. This really is the first thing that you need to tackle. Now, if we go and look at the final directions, so how you are actually going to communicate out your process, your findings, and you will see kind of what I'm talking about in terms of the engineering design process in the next video. So constraints, communicating, prototyping, that will be in the next video. But that communication piece, which is here, you are going to create a presentation with your group that you will then actually take a video of and kind of explain all of these different pieces. So at the beginning, you should be looking at the 7 things that you do need to have in your presentation. So the very first one is going to say, hey, what research did you do or what brainstorming did you do in order to start this process? So that's the first thing that I'd like you to do today. Like once you finish watching the videos, you are going to brainstorm first. And one thing that I'd like you to do is take one of the big whiteboards and kind of sketch out your thoughts first, and then bring those sketches to life by actually building. So that's your step 1. You should also be taking pictures of everything along the way. So you should be taking a picture of your whiteboard to put that in your presentation. You should be taking pictures of every one of your prototypes to put that in the presentation. So as you're utilizing prototyping, be sure to reference data, make sure that you have the images of that, and then there are several questions beyond that. So first thing you're going to tackle, brainstorming. building, and then forming this presentation. So on Friday, you will probably end the class maybe with half an hour left after you've done, doing all of your prototyping. You're gonna then do the math. This is what you should then get started on, is putting those pictures into the presentation and putting in some of the explanation pieces now, so that when you actually go to make the video, you're not spending forever trying to not only create the presentation, but then also recording. Hopefully you're putting these pieces in along the way. So notice that your video is going to be about 8 to 10 minutes. Images should be used as your predominant visual. So again, build, pictures, everything goes into this presentation. But overall, between Thursday and Friday, again, brainstorm, prototypes, start your presentation. We will get back together, obviously, on Monday. On Monday, we will go down to the stadium. You will drop your parachutes, and then that's where we will also do the physical challenge. So make sure that you are kind of dressed, ready to go down to the stadium, and you are dressed, ready to move when we get there. All right, email me if you have any questions, and have a good rest of your day.